Hello everyone, welcome to the 18th video in our Python for Artificial Intelligence and Machine Learning series. My name is Dheeraj Choudhary and today we will explore modules and packages, which are essential for organizing your code into reusable and maintainable components. As your artificial intelligence and machine learning project grows, the complexity of the code base will also grow. So these organizational tools of modules and packages are going to become increasingly important for managing your code base effectively. So a module in Python is simply a file containing a Python code. Just understand from the basic perspective. And module helps you organize related code into logical units, making your program more maintainable as they grow. Instead of writing all code in your one massive file, you can split it into smaller, focused modules. This promotes code reuse. Once you have written and tested a module, you can import and use it in multiple programs. So that helps you with the reusability of the code that you have written once, and multiple developers within your team can use it. Modules also provide namespace separation, preventing naming conflicts between different parts of your code. In artificial intelligence and machine learning projects, module help organize different components like data pre-processing, model training, evaluation, and visualization in separate manageable files. So let's understand that how creating a module is as simple as creating a Python file with .py extension and adding functions, classes, or variables inside that file. Each module have specific purpose. For example, if we take a data processing module processing processing functions, or model training module for training functions. So you can use a doc strings to document your module, and it's important making it easier for others in your team or the future self who is going to join in your place to understand how to use those. The special if name equal to main block allows you to code that runs only when the module is executed. So once we create the module, we are not going to test by calling that and seeing if it is going to give us the output. We are going to first run that module to understand if all the functions are running properly or not. That's why we use a main module inside the module block for our personal testing. And this is and in AIML projects, you might create modules for different stages of your pipeline, like data cleaning, feature engineering, model training, and evaluation. Let's understand how we create a simple module with a single file. So what I will do, I will go to our Visual Studio Code, and in this Visual Studio Code, I am going ahead and creating one file named maths.util. What exactly I have done in this file? First, I have given docstring where I have provided information about what this module is doing. Then I have declared the variable name over here, that is py. This is having a constant value. And the first and foremost thing that you should notice over there, that the file name that you are seeing over here, that is math_utils.py, it's in lowercase, so it's clear and it avoids conflict with any built-in modules if there is any. And it includes two functions. One is add and another one is area of circle. And we also have one class, that is class calculator. Okay. And if you will see over here, if name equal to main, we are using this. And over here, what we are doing is we are going ahead and doing some testing where we are checking whatever functions that we have created, that is add as well as area of circle, is giving appropriate output or not. If it does, then we are good to go ahead and use this module for further use. So I will just try to go ahead and run this code. If I run this code, you will see that the output will show me add test is equal to 12. So if you add 5 plus 7 is 12. Area of circle for 3 is 28.2741. And calculator, so over here we are multiplying 4 into 2 and the answer is 8. So this is how you can test your function by running the module directly. Okay. Now let's understand how we can import modules. So Python provides several ways to import modules, each with its own advantages. So the basic import statement brings in the entire module under your own namespace that you have created. So if you only need specific items from a module, you can use from module import that specific module that you're looking for. Both modules are imported items and can given you can also give allies. So if I'm saying if I am importing add from my specific add function from my specific module that I have defined. This is my custom module. You can take a built-in module also, and you can also provide an alias when you are importing that module. So further, when you want to use, you can use it. So for example, if I say import NumPy as NP. So if I do that later on, I will, instead of mentioning NumPy again and again, I am going to use NP. And while Python allows importing everything from a module with module import, this is generally discouraged in production code, as it is going to pollute the namespace and makes it unclear where functions are coming from. So never use star where you are going to import everything. So let's understand that with a code example. So if you go ahead and see over here, so when you are going ahead and saying import module name, what it is going to do is it is going to import all the functions inside that module. So right now we created a module math underscore utils. So we are having two functions and one class inside that. When I say import module name, that is math underscore util, it will import everything, which is not required. If you want only add functions, then you should only use the add function. You don't have to have the other area of circle as well as the class that we have defined over there as calculator. Now, that is why it is recommended that when you are using any specific function from module, you use from module name import that specific function or method that you're looking for. That's what we have said over here as item. Okay. For example, from math import square root. If you only want to use square root from the math, that is a built-in module of Python, you can just use that, right? Instead of importing everything, where it is also going to add bring in a lot of other methods which are not useful. So in production grade Python module usage, we are not going to do that. And as I said, for import, if I say import numpy as np, and later on I can use np dot array, np dot any functions of that specific module that we are looking for. You can do this also. So that is how you use it with alias. Now let's understand this with example. So if I go over here, I will close this. So first, before talking about the import for the built-in methods that we have in Python, let's talk about the import for the custom module that we have just created. So as you saw that the custom module that we have created, that is math underscore utils. So over here, what I'm doing is first I'm importing our custom module. So when I'm saying import math utils, it has imported everything. Now what I'm going is I am going ahead and calling the add function from it. And over here, I am giving 10 plus 20, and you will see the answer is, oh, sorry. First I have to run this. Okay, now if I go ahead and run, you can see the answer is sum is equal to 30. That is the addition of 2. Then if I take area of circle of 5 and I go ahead and run it, over here you can see this is the answer. And then when I go ahead and use the calculator, so it is using 4 3s are 12, and this is the answer that you get. So over here, what we have done, we have created the code once, and we can use it multiple times. So this is for our custom modules. Now we are going to talk about some specific examples of the other modules that we have available. So first we will start with talking about import math. So math is one of the module library that I will show you. Where is it? Yeah, over here. So if I go in Python standard library, if you go over here you can see numeric and mathematical modules. So these are the Python's library, that's Python's module. So if I go ahead, right click on it and open it over here, so you can see it is having a lot of methods that you can use. So you can use factorial, GCD, is square root, LCM, floating point arithmetics, a lot of things. Okay, so now I am going to show you that how you're going to import from the built-in module. So first way of importing is import math. Over here everything is imported, then I just use dot. After that I am calling square root. So where is square root coming from? If I search it over here, so this is the square root which is coming from the Python built-in module, that is mat.square root, and I am giving the value for which we want to get the square root. So if I go ahead and run this, it is going to give us the square root of 16. Okay, sorry, I have not printed the result here. So it is going to give us result of O. And here you get the answer, and it returns the answer in float, as you can see in the official documentation. So that is one way of importing the entire module. Then when you want to import specific functions only, specific items from the module, at that time you can use from math import square root and pi. So what I have done right now is, instead of importing all the items inside the module, I have just imported square root and pi because I am going to use that, and this is the recommended way of doing it. So if I go ahead and run this, it is going to give me the square root of 16 again, that is 4.0. So this is how we have just taken two items instead of taking all the items from the module. Now, next, in third, here we import square root from the math module, but we are giving an alias over here. So what is the alias? So for square root, the alias is square underscore root. Now, when you are going to use this, now we are going to once we use the alias, what we're going to do now is, whenever we have to invoke that specific method, we are going to use our alias. So many a times the names, which item names which are given as part of the inbuilt library, it is not clear and you want to change it so that it is well understood by others. So you can go ahead and change that too. So over here we have changed that, and you can see it will go ahead and give the same result as above. The same now in the fourth example, we import the entire NumPy module, but we are giving the alias as NP. So this is super common with big libraries like NumPy, Pandas, because it saves your typing for the long module names that you see. So instead of typing NumPy, that is 5 characters, you can just type NP, and it is especially for NumPy and Pandas, it is going to be very useful because you are going to use it often. So this aliases actually comes handy when you're going to go ahead and use this. So and last but not the least, in last example, we are using math import star, which is importing everything from the module into your current namespace. What it does is, it causes a problem if two modules have functions with the same name. It's easy to accidentally override the other one. Suppose if square root module is already existing, and if we are importing the entire thing from math, it is going to override it. So it is also unclear where a function came from. So it's best to avoid import star for because it is going to import everything inside your namespace itself. So this is a big red flag that you should avoid. Now, next. So now we are going to talk about module search path. So when you import a module, Python needs to find it, right? So it searches from modules in a specific order, starting with the built-in modules, then the current directory, followed by directories listed in Python path environment variables. Then it goes to the standard library directories, and finally it goes to the site packages where third-party modules are installed. So this is the hierarchy in which it goes. So first hierarchy is built-in modules. When you install Python, whatever built-in modules are going to be there as part of your installation, it is going to first see that. Then it is going to check your current directory by going to the specific path if that module is available. Then it is going to go to the environment variable. That is, if we take example of Windows, so you see that in our environment variable we have path where all the paths are added for the modules. So it is going to go ahead and search over there, as well as it looks for standard library directories. Okay, so let's understand this by checking. So suppose if I say import sys, and if I go ahead and print it, you can see from where it is going to go ahead and see. So it has got that data from the third one, that is environment variable. So when I said import C, it went to environment variable, and from here it got import this module with the help of the environment variable. That is example number one. Now, what if I have to provide a custom module that needs to be used by the program? So in that case, right now in my current folder, I have created a custom module that is math_utils, right? So what I can do, I can go ahead and provide the go ahead and add that path in the path environment variable. So later on, when I go ahead and say import my custom model that is mat_util, it is going to import it from the environment variable itself. That is one way of using a temporary path that you can add to your environment variable, and it can be used accordingly. Now let's talk about Python standard library, which includes a rich collection of built-in modules that provide functionality for common programming tasks. So let me go back over here. So this is the standard library of Python, and you over here you can see a lot of built-in modules that you can use. So this is the list. Okay. Now these modules are available in Python installation without requiring additional packages. Some particular useful modules for data science and machine learning work include math for mathematical functions, random for random number generators, date and time for working with dates and times, operating system and sys for interacting with operating system, JSON and CSV for handling common data formats, collections for specialized data containers, and idle tools and func tools for functional programming tools that we are going to use. So while external libraries like NumPy and Pandas often provide more specialized functionality for machine learning tasks, the standard library modules from a solid foundation and are often used alongside these more specialized tools. So familiarity with these built-in modules can help you solve many common problems without adding external dependencies. So let's understand that how you can import this external modules onto your machine. So as part of this example, we are going to import 5 to 6 different types of inbuilt modules which are available. So the first one that we are importing, what we are doing over here is, we are going to import math, which is a built-in Python module that has extra math functions not available by the default math functions, which already gets installed when you install Python. So when you write math.square, what it is going to do is you are calling the square function from the math module, right? And the math dot part means we are telling, hey Python, use the square root functions that's defined inside the math module. That is how it talks with Python in the background. Same with the factorial. So math.factorial 5, this calls the factorial function from the math module, and it goes ahead and gives you the output. And for math.py, it gives you the constant value of pi from the same module. So if I go ahead and run this, so for 5, the square root factorial is 120, and dot pi, the constant value from pi, is already been returned as part of the math module that we saw in the official documentation also over here. Here, this one. Sorry. Now, let's go back to our another example. So over here, first we are importing a random, that is a built-in Python module for generating random numbers and working with random data. So when you write a random.randint 1 to 10, you're calling the randint function from the random module, which is going to the randint function is going to pick random whole numbers between two numbers that you give. So over here we have given 1 and 10. So if we go ahead and run this, it is going to go ahead and pick a random number between this. Then next we are going to use random.choice items. So in this, what we are doing is this is another function in a random module. So it picks one random element from the list called items. So it could choose apple, banana, or cherry at random without us deciding to pick a specific element from this list. Now, third is nothing but it mixes the order of the items in your list randomly, like shuffling a deck of cards that we have. So it mixes up the order over here. So if I go ahead and run it, so that's what has been done. So one random number is picked from between 1 to 10. So next time if I run it again, see it has changed the random number, right? So second, if you see, it has picked cherry first time. So if I go ahead and run it again, it might pick something else because it is picking it randomly. Then we have a list of elements, apple, cherry, banana. If I run it again, you will see the order will change. Apple is same, but cherry and banana was there, but now it is banana and cherry. So this is how you can import the function from random and use it accordingly. Now, third, so here we are using date and time module. So this is a built-in module for working with dates and time. So from date time, we are importing date time, means we are pulling the date time class directly from the date time module. So we can use it without typing datetime dot datetime, okay, because we are importing a class directly from here. So datetime dot now is a method that comes from datetime class. It gives you the current date and time. Then now dot str, the other one, that is strf time. So it calls the strf time method for the datetime class, and it formats your date and time into a string in a nice format, that is year, month, date, hours, minutes, and seconds, which is very easy to read. So if I go ahead and run it, so you will see first when we ran datetime dot now, this is a current date and time, right? Then when I went ahead and I have given the formatted, that is strf time. So this is a formatted one which is going to format the return time based on our requirement. So we have formatted it based on year, month, date, hours, minutes, and second. So you see that this is the default one which comes, but when we format it, this is how it is coming, which is better to understand. Now in third, what we are doing is we are using strip time. It is another method from the datetime class. It takes a date string and parses it back into datetime object you can work with. So over here, what we have done, so we have given datetime str. So we have given a string over here. So it has actually parsed that string into date and time. So if you go ahead and see 2024, this is the month and this is the date. So we are saying that this is our string, parse it to date and time field, and date and time field is going to have the format as year, month, and date, and rest is as it is. So as we have not defined, so it has came as default. So this is how you can parse a string into a date. Now another example. So in the fourth example, what we are doing, we are going ahead and importing OS and sys. So both are again Python built-in modules for interacting with your operating system as well as Python environment. So os.getCwd calls the CWD function from OS module. It stands for get current working directory. So whenever you run this command, it is going to get the current working directory for you. So this then comes os.list directory, and I have given dot inside that. So this calls the list directory function from the OS module, and it is going to list all the files and folders in the directory you give it. So right now I have given dot, which means it is going to give all the files and folders which are there in our current directory. That's how the full stop works over here. Now third, we say sys dot version. So this uses the version variable from the sys module. It shows you which version of Python is running, which is useful if you need to make sure your code works with the right version before performing the task that you want to. So anytime you see OS or sys in your code, you know exactly where these functions or variables come from. So it's better to run it. And over here you can see my current directory is this. My files in this current directory are all these that you can see, as well as the folders which are been listed over here. And the current Python version that I'm working on is 3.11.9. Now let's talk about our another example. So over here we import JSON and CSV. These are again built-in modules for working with JSON and CSV data formats. So JSON.dumps data calls the dumps function from the JSON module. It takes a Python directory and turns it into a JSON format string. So whenever we are going to run this code, JSON done. So what it is going to do is, it has JSON string, right? So it is going to change this data that we are providing into JSON. So if I go ahead and run this, you can see now this has been changed to JSON format. Okay. Now CSV.writer. So what CSV.writer does is, it uses a writer function from the CSV module. It creates a CSV writer object that lets you create a rows to a CSV file. So writer dot write rows that you see over here, writer dot write rows calls the write rows method on the writer object, and it writes multiple rows like your headers, your data into a CSV file all at once. So whenever you see JSON or CSV in your code, it means you are using these specific tools or functions that you would be working on. So now it is saying that CSV file written is people.csv. So that is how you can read the rows and you can write the rows by using csv.writer over here. Okay. So if you see people.csv has been created, if I click on this, you can see whatever we have read over here, the 3 rows, it has been added to people.csv and the new file was created. So this is how it works. Now, next, over here we are going to import counter and default dict. These are the collection modules that is built in a Python module with a special container type that goes beyond normal list and dictionaries. So counter over here uses the counter class from collections. It counts how many times each item appeared in a list. So here it is going to count how many times each color appears. So if I go ahead and run this, okay, so it has gone through the entire list and it has given us the output saying that blue has been defined 3 times, red 2 times, and green once as part of this list. Okay, now moving to the second one, that is a default dict. So it uses the default dict class from the collections and it creates a dictionary that automatically gives you a default value. So here is an empty list that you see. So you don't get an error if you try to add a key that doesn't exist yet. But if you already have that key, it might give an error. So anytime you see counter or default dict, you know how you can use these tools now, right? So when we ran this, it went ahead and it has appended. This is the default list. It iterated in towards this list and 2 items has been added, that is apple and banana, as part of this list. That is how you can use default dict, that is collection. And you can also use iter tools. So this is another built-in Python module with powerful functions for looping and combining data. So iter tools dot product, the first line that you see, what's happening over here is, so 1, 2, A and B. It calls the product function from the iter tools and it gives you the Cartesian product. So all possible pairs from the tool list. So if I go ahead and run it, it is going to give us all the possible pairs for both of them. So first it has taken the pair of 1 with A, then 1 with B, correct? Then it has taken the pair of 2 with A, then 2 with B. So that is how it performs the Cartesian product. Now, talking about the other one, that is iter tools dot combinations. So over here we are using 1, 2, 3 and comma 2. Okay, so it calls the combination functions from the iter tools module. So it gives you all the possible pair of items from the list of 3 numbers. So that is what it has done. Same like the Cartesian products, this is the combinations, where this time again it has returned a list with 1, 2. So the first combination is 1 and 2, second is 2 and 2, and third is 2 and 3, right? So this is doing combination of 1, 2, 1, 3 and 2, 3. Different combinations it is coming up with and it is giving it to you. Now, last but not the least, finally, func tools import reduce. So what we are doing over here is, this is again a built-in function. So reduce lambda we are using. It calls the reduce functions from the func tool. It takes a function and a list. As you can see over here, it has taken a function and a list. So the function is lambda and the list is numbers over here. Okay, so it calls the function and a list and it reduces the list to a single value. So here it is going to add all the numbers together, that it is going to add 1 plus 2 plus 3 plus 4 and it is going to give you the total sum. So if I go ahead and run this, so you can see what it has done is it has gone ahead and provided you the direct answer for the operation that you have performed. So over here it has looped onto your entire list with lambda. Once it has looped, it has gone ahead and given you the final output of the operation which has been performed, that is the final value of x after it has iterated over all the elements inside this list. Okay, so next we are going to talk about packages. So as your program goes, you might find that even organizing code inside the module isn't enough. So this is where packages comes in picture. A package is a directory, as you can see in the image, containing multiple module files and a special init.py file that marks it as a package. So when you add init.py file, then and only then Python understands that this is a package. Packages allows for hierarchical organization of modules, making it easier to manage large projects. They help avoid naming conflicts by creating separate namespaces for different components. Many AI/ML libraries like scikit-learn, TensorFlow, and PyTorch are organized as packages, often with some sub-packages for different components based on your requirement. So if you see in the example, we have created a ML project in which we have segregated different sections. So for data, we have created one folder inside ML project. For modules, we have created one. For evaluation, we have created one. So inside ML project, you can see we have multiple packages. So the first package is data, second package is modules, third package is evaluation, and fourth package is visualization. So let's go ahead and do one thing. Let's understand this in a more better way. So how we create packages. So creating packages is really straightforward. What we do, first we are going to go ahead and create a directory with a meaningful name for our package. Once we create that package, inside that directory, we add init.py file, which can be empty, but it marks the directory as a package. Okay. Then you add your module files. So right now, in the start of this tutorial, we created math_util.py. That was one of our module file, right? But you can add multiple module files if you want as part of this specific directory that we would be doing soon. And the init.py file serves several purposes. It runs when the package is imported. You can import specific modules or items to make them available at the package level itself. And you can also define all the controls, what's imported with the from package import star syntax. You can also add package level libraries like version numbers. So in implementation, this is how it will look. So let me go ahead and minimize this first. So over here, what we are going to do is we are going to create one. So what I have done over here, so this is the hierarchy that we are going to create. So we are going to create one folder named myutils. Under this, we are going to create init.py file. This init.py file is going to tell that this is a package. Okay. Then we are going to create two files, that is math_tools and string_tools. So if I go ahead, so this is our folder, myutils. Inside this, I have created three files. First file is math.py, second is string_tools.py. So these are the modules that we have created, two modules, and this is last the init.py. Now let's run through all of them one by one. So inside our math_tools.py, so this is a file that is a module that holds your math helper functions. There are two helper functions over here. The first one is add, the second one is subtract. So when you are going to call this module and pick this call this package and pick this specific module inside this package and call the method over here, that is add or subtract, provide the arguments, it is going to give you the addition and subtraction, as you can see, as part of this code. Then the second one is string tools. So over here, what it is doing is when you are going to use sh shout, so it is going to make the string that you are passing as an argument into uppercase, and if you are going to say whisper, it is going to make the string whatever you are passing into lowercase. So that is how string tools are going to work. Now coming to the important one finally, and that is init.py file. So this marks the folder as a package, as we said, and it is going to control what happens when somebody is going to import myutils. So inside this file, you can import only what you want to make available. So this means whenever someone does from myutils import add shout, they can directly use add and shout without needing to write it again, right? And the last you can see underscore all underscore. This list makes sure that only the functions you list are available when somebody is going to use import star, that is going to import everything. So whenever somebody says import star, it is going to go ahead and import this 4 functions as part of the package that we have. So if I go ahead now, as we have created the specific package, so what I'm doing is I am saying from my utils import add and shout. So over here what I have done, I have given 2 3, so it should give us the addition of 2 and 3 because we are calling the add function from math tools, and we are calling sh out, which is going to convert this string. So if I go ahead and run this, so this is how our package is created, and this is how we are utilizing the module inside those packages. So you can see over here what I have done. So it has given the addition of 2 and 3, and it has modified the string that we have provided into uppercase by using the function that we have defined. Okay, so next we are going to talk about importing from the packages. So right now I showed you how you import from the packages. So you say that import package dot module. So if you see over here what we have done, import package dot module, that is one way. Another way is you can directly say from my utils import add and shout. There are multiple ways of doing it. Okay, so what are those multiple ways? I will show you over here in our examples. So before going to examples, let's understand how exactly it works. So you can import a specific module from a package. You can import specific items from a module in a package, or you can use relative imports within the package. So relative imports are going to use dot notation. A single dot refers to the current package, 2 dots refer to the parent package, and so on. You can use the dots accordingly, as you can see over here. So from dot import module, that is from current directory, if there is any package, import module parent directory, that is dot dot, then that is how you can use the dot accordingly to import it. And this is particularly useful for imports between related modules within your package. So when working with large AIML code bases, proper import practices help maintain clean code and avoid circular import issues that usually we face. And relative imports are especially helpful in complex package structures like those found in machine learning libraries, where components often need to reference other components within the same package hierarchy. So in our first example, we import the whole math underscore tools module inside the myutils package. So to use a function, we can write myutils dot math underscore tools dot add. So by doing this, what we are doing is, so first we have imported the entire module. Okay, once the module is imported, then we are just going ahead and calling our items inside the modules that was the part of the package. So this is the entire package imported. So package and the module within the package. Now, when you want to import a specific module, so what you do is you can say from my utils import string tools. So it is the same way that we have done over here. What I have done, import myutils.math. So over here what you have to do is, whenever you write in this way myutils.math, so whenever you have to call the item within the module, every time you will have to use this long string that you have mentioned over here. So instead of that, when you say from my utils import string tools, so directly string tools dot item. So this reduces your name that you're mentioning over here. So this is how you can import your module from the package, which reduces the text that you're writing for. Okay, now the third, so over here we are going more direct. So from we are saying from my utils dot math tools, so we are directly going inside a specific module, and we are only importing one specific item from that specific module. So this is how you can do it. So for the second one, I forgot to run, this is the output, and for the third one, when we are going to do, it is going to provide us the subtraction. So this is how what we have done. We have just imported the item from that specific package inside, and from the specific module inside the package that we have just created. Now let's talk about the best practices for package management. So proper package management is crucial for maintaining and reproducible machine learning projects. Every project should use a virtual environment to isolate its dependency from other projects. So usually when we are working in real time, so what we do is, right now we were just talking about the modules, right, and the packages. But there are other packages also that I just spoke about, that is NumPy, Pandas, which we use in real time. So whenever you install them, there might be projects where you're only going to use NumPy. There might be projects there where you're only going to use Pandas. In one project, you will use PyTorch. In another project, you will use TensorFlow. So instead of mixing or instead of installing everything on your machine, instead of that, what we do is we go ahead and create virtual environments. Once we create the virtual environments, then based on our project, we can go ahead and add or install the packages accordingly. Now, document all the dependencies in your requirement.txt file. So whenever you are installing a package by using pip install, make sure that you document all those installed packages as part of your project into requirements.txt file, including the specific version numbers, to ensure that consistency is maintained across all the installations which has been done for that specific project. And for scientific computing, Conda is often preferred over pip as it handles binary dependencies better compared to pip. And organize your project with the clear directory structure as I showed you. And if you're creating a package for distribution, use setup.py to define installation requirements so that people can go through it accordingly. Always document installation steps in your project README and be aware of licenses uh, of packages you use, especially for commercial projects, because every packages comes with some guideline of the usage that is been done with them. And these best practices might seem like extra work initially, but they save significant time and frustration as your project grows in long term and when collaborating with others and deploying models to production. Now, last but not the least, let's talk about some external packages installation. How you install external packages? There are multiple ways of installing it. One, I said you can use Conda. Another, I said you can use pip. And when you use pip, how you install it? You can just go ahead and use the inbuilt command of pip that you don't have to install again. You can just say pip install the package name, that is pip install NumPy. It is going to go ahead and install NumPy. Then you can do it in multiple ways. Let me show you how you can do it. So how to install external packages? First way, go ahead and say NumPy. It is going to go ahead and install the latest version of NumPy. But trust me, when you're going to work on projects on a specific framework, that is TensorFlow or PyTorch, you will have to use specific NumPy version, because many of the things that you're implementing is either supported or not supported on that specific version. So you have to be very specific about the version that you're using. So in that case, what you do, you say pip install NumPy equal to the specific version that you want to install for NumPy. Now, the best practice is whatever you're installing, like pip install NumPy or pip install NumPy to a specific version, go ahead and add that into requirement.txt into your project. So later on, if somebody is going ahead and implementing that on his end, he can go ahead and just install those as part of their machine installation so that they don't face any issues. So the way your project is going to run on your specific machine, it will run across on everyone's machine in your team. Now, many times while we are coding, what we do is we go ahead and keep on installing packages based on the errors that we are getting. In today's world, ChatGPT says that this package is missing, go ahead and install, right? But we don't remember what we have installed. So what you can do, you can go ahead and say pip list. So pip list is going to list all the packages that you have installed. So the best practice of doing it in real world is, what we do is we go ahead in a project, we create a virtual environment. Once we create the virtual environment, then based on our project, we go ahead and install each and every package based on our requirements. Once it is done, what you can do is you can go ahead and use pip freeze, and you can say requirements.txt. So in this way, what will happen, whatever libraries that you have installed whatever packages that you have installed inside your environment file, it is going to all go ahead and save in requirement.txt. Once it is saved, then later on if anyone wants to use it, they are just going to install it right away by using this command. It will say pip install -r requirements.txt. That means it is going to install all the packages listed in that txt file. This is how you install your external packages, and this is how you set up your virtual environment setup by using a virtual environment, that is env, venv, virtual environment. Now let's talk about the official Python documentation, which is very important. So I am going to show you 3 official documentations. So the first one is the modules. This is the one which talks about modules in detail, how modules work, then different types of ways of implementing it. The same as I showed you. You can use import star. You can import a specific item. You can import it in another way where you are importing the Fibonacci series. Then what is the benefit of using underscore name is equal to main? Why it is important for testing your module before you are making it available to others. Then the module search path that we spoke about, that how you are going to define your module search path, and how actually it in the backend it it is going to go ahead one by one. Like first it is going to go ahead and check whether it is in your current directory, then it is going to go ahead and check whether it is in your environment variables. So all that are been mentioned over here properly, and it is better to always read the official documentation so that you don't deviate from any outside information. Now next important thing that you should be aware of is Python standard library. So this describes the syntax of each Python language semantics which are been mentioned. So for example, we took math. So if I do math, so you can see that mathematical functions over here. So this is what we used. But apart from this, I also showed you that how you can use IDA tools, how you can use punc tools, how you can use OS, how you can use OS path. So there are multiple libraries which are present over here. So this is OS that we used. Then you can use logging.config to log the activities that has been performed from your program. So all these are very important and handy. So make sure you have a look at this. I will go ahead and put all these links in the description of this video, so you can go ahead and check it. Last but not the least, the import system. So in this, it helps you understand that how the import works, what is the import system. So how are packages imported, what are regular packages, how the package searching is being done, then the module caches, the finder and loaders, import hooks, the meta path, a lot of things. So this is how it is loading. So you can go ahead and check this official documentation too. It will be really very helpful for you. Now, thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions, feel free to put them in the comments below. I will try my level best to answer them. Remember, programming skills improve with practice. So try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our AIMN channel, and sign up for Tech Inside Neuron newsletter, where I am going to go ahead and also share a lot of documentation later on. So over here you can see we have a QR code for joining this community, subscribing to the YouTube video, as well as joining the subscribing to the newsletter. I am also going to go ahead and put those links in the description below. So see you in the next video. Take care and bye for now.